Hey class, what we're going to do is we're going to take a look at number 5 and try to figure out what is the angle measure between these two vectors. So if you want to take a minute, pause this, and then read through number 5 so you can understand where this vector 4, 9 and this vector 3, 8 came from. Now that you're done pausing it, what we're trying to find is we're looking for this angle theta. We know from previous work that the angle for this vector is 66 degrees. One way of trying to find angle theta is to find the angle for the vector that goes to a negative 3, 8. And if I can find that angle, call it alpha, then alpha minus 66 degrees will give us theta. Well, to find alpha is going to be equal to 180 degrees minus this right angle in here colored red. I'm just going to call that little b1 for beta sub 1. So if I can find beta sub 1, then I subtract it from 180 and I will have alpha. Well, beta is just a right triangle with vertical component of 8, horizontal component negative 3. Therefore, b1 is equal to the inverse tangent of 8 over negative 3, or about 69.44 degrees. So 69.44 degrees. Therefore, alpha is going to be 180 minus 69.44, which gives us about 110 or 110.56 degrees. So if alpha in our picture in red is 110.56 and theta from previous work is 66, the angle between two vectors, theta, the angle between two vectors is then equal to 110.56 minus 66 degrees, which gives us approximately a 45-degree angle. Now, what we're going to do is I'm going to talk a little bit about number 6 in the book and try to discuss what this dot product is. So if you need a minute to pause this, please do so, especially if you want to read anything in number 6 or take a look at the picture at the bottom of page 135. Okay, ready, class, to have your mind absolutely blown. I'm not going to give you everything in number 6. You can take a look at the answers that are in the notebook file. Basically, we want to try to find alpha, the angle between vector A and vector B. Now, to do that requires a lengthy, absolutely stunningly gorgeous proof using the distance formula, where d squared would be equal to x1 minus x2 squared plus y1 minus y2 squared, combined with d squared being written using the law of cosines. But out of due respect for you and not trying to absolutely bore you to death, I'm not going to get into it. Basically, after trying to put those two equations together, the cosine of alpha is equal to x1 times x2 plus y1 times y2 over x1 squared plus y1 squared times the square root of x2 squared plus y2 squared, which is equal to what we call the dot product of vector A and vector B over the resultant of vector A times the resultant of vector B. And forgive me as I misspoke, that is the dot product of vector A and vector B over the magnitude of vector A times the magnitude of vector B, which simply by looking at the formula, the magnitude of vector A is just your Pythagorean theorem for the coordinates of vector A times the Pythagorean theorem of the coordinates of vector B. So that's what's in your denominator. In your numerator, it's the product of your x's plus the product of your y's. We are going to use this formula to attempt to find the angle between two vectors as in part 8, which is on the next slide.